Hey everyone, and welcome. Today, we're going to tackle a huge challenge facing anyone building with AI right now. How do you get these amazing LLM applications to be fast, cheap, and reliable enough for the real world? Well, we're going to dive into a super powerful pattern that gets you the best of both worlds by combining two different kinds of AI into one seriously robust system. All right, here's what's on deck. We're going to start with a problem that I bet a lot of you have run into when using large language models out in the wild. Then, we'll introduce the solution, the hybrid agent, and see exactly how it works, cover the very real benefits, and wrap up by looking at why this is such a key pattern for the future of AI.
Okay, so let's get one thing straight. Large language models like Gemini and GPT are absolutely incredible. No question about it. They've totally changed the game. But, and this is a big but, as a lot of developers are finding out, trying to use these powerhouse models for every single little task can lead to some pretty serious headaches.
So let me ask you this. Have you ever built a mind-blowing demo with an LLM, something that worked perfectly, only to watch it kind of fall apart when you tried to push it into a real-world, high-traffic application? Yeah, if that sounds familiar, you've hit what we call the production wall. See, here's the fundamental disconnect. The promise of LLMs is this amazing world of dynamic thinking and quick, conversational answers. But the reality, especially when you're trying to scale up, is that using a giant, powerful LLM for simple, repeatable jobs can be painfully slow, it can cost a fortune in tokens, and honestly, sometimes it's just not that reliable.
So what's the fix? Well, it's not about just throwing an even bigger, more expensive LLM at the problem. Nope. It's about working smarter, not harder. And that's exactly where our solution comes in, the hybrid agent.
So what exactly is a hybrid NLP agent? Well, think of it as a system that brilliantly combines the best of both worlds. You get the predictable, lightning-fast speed of a small, specialized tool, something like spaCy, and you pair it with the deep, sophisticated reasoning of a large language model. It's really all about using the right tool for the right job.
The whole idea boils down to something pretty simple. You don't use a sledgehammer to crack a nut, right? Think of it like this. The LLM is your brilliant senior-level strategist. They're amazing at complex, high-level thinking, but you wouldn't ask them to do basic data entry. You delegate that to a hyper-efficient junior analyst. In our case, that analyst is spaCy.
Okay, so that's the big picture. But how does this thing actually work in practice? Let's pop the hood and walk through a real-world example. I promise, this will make it all click. Let's imagine a big company. Every single day, they're getting flooded with hundreds of emails and chat messages. Just a total mess of unstructured text. The goal? To automatically figure out what each message is about and send it to the right department. Sales, legal, finance, you name it. All without a human having to touch a thing. And of course, they need to do it super fast and without breaking the bank. The whole process is actually a pretty simple three-step flow. First, that messy, unstructured query comes in. Step 2, our fast, specialized tool, spaCy, instantly scans it and just pulls out the important bits, like company names, dates, things like that. And then, Step 3, only that clean, structured info gets sent to the big LLM, which can then easily use its powerful brain to make the final call on where the message should go. And here's a cool little detail that shows you just how specialized this first tool is. Look at the name of the model we're using, N-Core Web SM. You can literally decode it. N for English, Core because it has all the standard parts, Web since it was trained on internet text, and SM for small. It is the smallest, fastest, most efficient model for the job. Perfect.
So that first component, spaCy, is our speed layer. And the secret to its speed is that it runs locally, right on the application server. This means its task, which is called Named Entity Recognition, or NER for short, is just blazingly fast. We are talking near instantaneous, no waiting for a network call.
Then you have the reasoning layer. And this is the really clever part. The large language model is specifically told, hey, you are not to read the original raw message. Its instructions literally say it must use the output from our spaCy tool. So it just waits for that neat, clean, structured data before it does any of its high-level thinking.
All right, so you might be thinking, okay, that's a neat setup, but is it really worth the effort? The answer is a resounding yes. The payoff here is huge, and it's totally measurable. Let's dig into the tangible wins. You're basically looking at three massive advantages with this hybrid approach. You get serious cost savings, a huge boost in speed and predictability, and way better reliability across your whole system. Let's break each of those down.
First up, and this is a big one for everybody, cost. Just imagine sending this entire long sentence to an LLM. Regarding the merger,
can you tell me the exact acquisition date agreed upon by our legal team and Acme Corp? You get billed for every single one of those tokens, which adds up really, really fast.
Now look what we send instead. Our local spaCy tool chews through that long sentence and spits out this tiny, perfect piece of structured data. We just send this to the LLM. The token count absolutely plummets, and so does your API bill. It's a night and day difference.
Benefit number 2, speed. Remember how I said the spaCy tool runs locally? Well, that means its job is deterministic, predictable, and it's done in the blink of an eye. This slashes your overall response time because you're not making your user wait for a slow network API call for the easy part of the job.
And finally, we have reliability, which might just be the most important benefit of all. Because spaCy's output is predictable, it gives you the same answer for the same input every time. The LLM gets a solid, verifiable foundation of facts to reason from. This massively cuts down on the chance of errors or those weird AI hallucinations we hear about.
So let's zoom out for a second and look at the bigger picture here. This hybrid agent idea isn't just a clever one-off trick. It actually represents a fundamental pattern for how we're going to build the next generation of strong, reliable AI applications.
To sum it all up, this is how we get AI out of the research lab and working reliably in the real world. By giving the fast, predictable tasks to specialized tools, we free up our amazing LLMs to do what they do best, that deep, complex reasoning. And that's how you build apps that are efficient, tough, and truly ready for production.
So I'll leave you with a question to chew on for your own projects. Take a hard look at your workflow. What simple, predictable, deterministic tasks are you currently paying an expensive and often slow LLM to do? And just think, how much faster, cheaper, and more reliable could your entire system be if you delegated that work to a small, specialized tool instead?